Hi, everyone, and welcome to the second day of the Connect conference. So, yesterday we opened up the conversation about collaboration, and really together we looked at what different collaborations, different sizes with different goals look like, and how different people come together to work on a research project. And today we want to go from this exploration a little bit more to creating momentum to do more collaboration and more um, working together. And we will continue showing some collaborative research in action. There are a few really interesting talks that are happening after this session, and then there will be breakout rooms that I'm sure Britannia will share more details about that. But before any of that, and to start us off, I'm very excited to have a deep conversation with Ivan. Ivan is the co-founder of Cohere alongside Nick and Aiden, and he oversees the key technical product development and is closely involved in the company's public sector and government customers. But maybe even more impressively and importantly for this audience, he is also the co-founder of For AI movement, and which turned into Cohere for AI after a few years, and which is now what we call Cohere Labs. So really good to have you here, and I want to hear, and I'm sure everyone wants to hear more from you. How are you?
Hey, I'm happy to be here. I'll continue the tradition. I'm in Ottawa. There's snow on the ground, and it feels like -5. So Ottawa, Canada.
Oh wow. So that's yeah, I'm not gonna complain about like in Amsterdam now, I think it's like 4 degrees. Like it's not it's not too bad. But I love to see some snow this year. Yeah, it's been a while. Yeah, great to have you, Ivan. So I want to start off by just asking you about the early days of 4AI and really what sparked this. Before it was really cool and this buzzword of collective work, working in a community on research. What really sparked that and how did it start?
Yeah, great question. So for me, it's always fun to think about those times because it was a much simpler time in the ML space for sure. In 2017, I was sort of mid-career in my like software engineering journey. At the time, I've only worked on like back-end systems, write and go, like worked on products. And there was an opportunity to work with Aiden, who at the time I had no idea, it was pre-Transformers, so who's Aiden Gomez anyway? Don't tell him I said that, but really it was curiosity driven, right? Like so Aiden had the idea to start a lab. He wanted to publish some papers, and he sort of blasted this message to the U of T, University of Toronto Computer Science community, where he was looking for other collaborators to just independently work on some papers together. And at the time, you could get away with, one or two GPUs to run enough experiments for your papers. And so it was a plausible, endeavor. And so I was curious about AI. I had some exposure to it. I certainly knew, one of my first programs was like a chess AI, right? And that was with like mini max algorithms and stuff like that. And so neural nets were pretty interesting to me, sort of mid-career. And so, it was curiosity driven. I wanted to learn something new. It seemed like a fun thing to do after work. And so we linked up and started working on for AI.
And how was so I guess you were at the University of Toronto, so that makes sense to launch it there. But like, how was the experience of working, like starting this in an academic setting with really like research-driven minds?
Oh, it was totally independent. So nothing like
Oh,
U of T had nothing to do with it, to be honest. It honestly started on Slack. Like we had this
oh.
like free version of Slack for all of the department, like all the students and stuff like that. And we just started working together. He ran like a trial process to, weed out who's capable enough to contribute, which is I think we were all building autoencoders in TensorFlow. And yeah, it was just like there was like a cohort of like 15 people We all like ran through the exercises. We like, eventually trickled down to like maybe 4 or 5 collaborators after that. And then we would meet up in the same building where Jeff Hinton's lab was. And I think Aiden was working with Roger Gross at the time. And so he had a desk there. And so he hosted, the survivors of the autoencoder TensorFlow exercise. And we would meet there and just discuss some potential research ideas. Um, and yeah, like I think we landed on a few. Like we thought a lot about like computational, like atomic computations, right? Like addition, subtraction. And then there was like and then Psychogans had just released. So that was like the most hyped thing at the time. And so it captured all of our attention. And so we were like, oh, what if we applied the same concept? So Psychogan was like you take two GANs and they try to like trick each other on how to best create images of two classes. So the paper itself, they did like I think it was pictures of horses and zebras, and they would like try to trick each other by generating good pictures of horses and zebras. And so we wanted to take that same concept and apply it to language, so text, which is very different, right? Like obviously images is a more continuous space, and text is more discrete. And so we need to solve for how to do this in a discrete space. And so that was super fun. And it didn't take that much compute to start with, right? I mean, at the time it was a lot of compute, but we were very scrappy. We were, after work, right? After our day jobs, we would meet at U of T, not in a sanctioned environment, not a sanctioned program whatsoever. And there was some free compute lying around. And so maybe we would do a training job here and there to support the results we needed on the U of T cluster. Thank you for that. And so yeah, I mean that's really how we got started. We just decided to do it. We just decided to do the thing.
Yeah, I love that. Actually, 2000, you said 2017, was it?
Yes, this was yeah, like
Yes,
2016, 2017 era, right?
2017.
This was
Yeah,
like pre
that's
yeah,
actually,
GANs were like the thing, right? This is like
yeah,
when Ian Goodfellow had that like incident with yeah Schmidt-Huber. That was that era
yeah,
of
the
ML.
famous NeurIPS
Yes,
panel.
exactly.
Yeah, I actually that's funny you mentioned trying to do this cycle again in replicate that in language. 2017 I was in the middle of my PhD, and it was the time that neural networks in computer vision, they showed a lot of really nice promise in the beginning of getting that into language. And one of actually my first paper was inspired by data augmentation techniques in computer vision, applying that to language, and how similarly with vision it's always really, well, relatively easy to you don't use semantic meaning by flipping an image or like blurring it or like making these modifications, but with language it's a whole different story. And kind of I feel like that was also around the time that generally research began to like different fields began to merge together, and in these
Mhm.
interdisciplinary, like getting inspired from one field and do that in another field, and that kind of ends up where we are now, that we have this really one architecture and one model that can do all of that.
Yeah, honestly, it's so different back then compared to now, right? Like back then we had different neural nets for different modalities. Now you have sort of these omnimodal architectures. It's super exciting to see. Yeah, it's just
Yeah,
information at the end of the day now.
yeah. I do want to ask you about this because that was also the area that toolings were not really, in terms of also like everyone switched from Lua to Torch to PyTorch to TensorFlow, like every year was something different. And the community driven work to improve each of these and share the learnings was really important to what becomes now, I think, how like PyTorch for the most part is now dominating this technology. And how much of that, like how much of this like learning together something new that no one else knows how to get that to work was uh, maybe you think was possible through this like for AI community, and maybe couldn't have been done in another way. So just like motivated people just pushing to learn to get things working.
Yeah, I mean, look, I think at the time, right, like, TensorFlow at the time felt developed, right? It felt like, oh, they've already solved machine learning, they've already solved all these training problems. But as we see now, that's very much not the case. There was so much more innovation and frameworks and technology built on top of it. Even we moved to JAX, right? We moved to PyTorch. That's how the ecosystem evolved. So I think every generation of technology, there's like so much more that could be optimized or improved upon. The constraints we had at the time was like resources, right? Like we were a small lab, independent, and so we had a very specific problem set, but we had a very different skill set as well. So I came in with my background in software engineering and managing infrastructure. I was able to build tooling using my skills for us to better manage our experiments, better manage our compute clusters. And so you just have to be creative, right? And again, if you're doing independent research, you need to be scrappy. Use whatever's already built, just use that, right? And if it's good enough at solving your problems, but then focus your differentiators on the differentiating stuff, right? If you're particularly good at some sort of tool set or language, like you could use that to build a really great eval for that space, or construct tooling around that area so that your research could be better there. But really, you have to have that like grit to just like keep trying things until it works. I think that's really I've seen so many independent labs throughout my journey in ML, and the ones that survive really is just some like ungodly amount of determination to make it work. And I think that's really the difference maker. It's not like your backgrounds or whether you have a PhD or anything like that. It's just successful research is done by people that don't give up.
Yeah,
So
persistence, perseverance, definitely. I agree. And then I'm curious because so after 4AI, you started Cohere, but then what was still like stuck with you, and also Nick and Aiden, that you made you go back to creating Cohere for AI at the time and now Cohere Labs? So like what memory that you wanted to follow from the early days of 4AI, and what was really the main goal to start this research lab?
yeah, I mean there's obviously like the like business reason, which is like it's great to have a vector to deliver research in a way where we can still collaborate with other companies. It's so therefore it had to be independent, and we could still publish some of the work that we do for to innovate for our customers. But for Aiden and I, we really wanted to pay it forward, right? For Nick, Aiden and I, we want to pay it forward to back to the community, because for us, for me in particular, right? I mean, Aiden obviously, he had Google Brain, he had Oxford, and all these great pathways to ML. But for me in particular, I was really an outsider coming in to machine learning. I had really no reason to be there, like truly. I dropped out of school. I dropped out of undergrad. I was a software engineer. I had no training whatsoever in math and ML. Actually, I dropped out before I even took the ML course at U of T, which is interesting. Um, but I really had no reason to be there. But it really, I feel like I'm the existence proof for, hey, like given the right environment, the right support, the right access to resources, I was still able to be useful, right? Like I could still find a way to be useful in the research environment. And so part of it was, yeah, like let's pay it forward, right? Like I was supported by many mentors and systems along the way to support us. So Google, for example, they supported us with the research cloud, right? So 4AI was one of the first external users of the TPU, right? And then Cohere became that as well. So and then, of course, U of T and Vector giving us spaces, giving us mentorship. A lot of profs along the way gave us that. And so I was lucky enough, like me personally, I was lucky enough to find that pathway into ML, and I was able to contribute massively. And so 4AI was a way for us to manufacture that luck. So could we find others like me who might have never gotten to ML if there was no pathway in, and then like I couldn't have built all this cool stuff. And so yeah, well, I wanted to pay it forward, and I wanted to have a vector for you come from an untraditional background, you could potentially be useful for ML. Let's explore that connection. Maybe there's a connection there, and of course, it's been successful, right? We've had so many scholars and people from the community who ended up actually joining us full time and contributing massively to our architecture.
Yeah, one thing we are really proud of is just trying to find these like diamonds people around the world, really globally, who just need that initial help and boost to make the connection, and they have this really this fire inside them that we see how in the research that we work with them, in the scholar projects, in community projects, how they really do things that no one has done before. And then they join Cohere, and they make huge difference in the teams that they join. So it's really great that this is and it's also part of what I'm very proud to be part of this lab, and really proud to work with these people. I do want to get your thoughts on right now with this, especially with this sort of like this global research ecosystem that we have in this community. What do you think are interesting research questions that people should be thinking about? And also, it can be like what is a little bit maybe overhyped, and like maybe something else that are underappreciated that more people should be working on.
Yeah, I mean, top of mind for me is like, I think we've solved, I think there's been a lot of progress made on the generalization of the transformer. I think you can build like pretty decent agents now, but there's probably still some more work to do to like understand agents better and make sure that, they work well in a production setting. And so that's things like research on the harness, research on prompt engineering, research on like, is MCP like the best way to present, a way for the model to feel the environment around them. And then of course there's, yeah, if I didn't mention evals already, evals are the most like difficult problem right now because nobody wants to build evals, but also they're probably like the first thing you should do before you start constructing an AI system. So agents is very interesting to me, and then also applying the technology to different like domains is also very interesting, right? Like, yes, they're generally useful, but like, how good are they at cybersecurity? Like, how good are they at sciences? How good are they at like, doing like chemistry, right? And can we figure out what are the paths that we need to discover and research for this AI agents architecture, with transformers maybe, to do really great chemistry, right? And again, it starts with the evals. So I think a great set of problems I want to see solved is like the labs, us, right? Like and some of the other labs, we've built this intelligence that's we've tried to build this very general intelligence that's like smooth across the board, but evidently it's very jagged, right? If you look at what AI agents are like today, like they're very good at particular things and very spiky in performance. But it's very much not that general yet. And so as a research community, like I challenge the research community to give us better evals to understand the jaggedness better, right? So having even just better visibility over where the spikes aren't, um, and then potential techniques to solve for the jaggedness.
No pressure for everyone, but yeah, so solving the eval problem. Yeah, it's very much, I agree. I do think so really going beyond with evals, measuring individual metrics and numbers, but really this out of distribution, real world performance and behavior understanding of the models. Easier said than done. And it is kind of a catch-22. If you already have that, you already probably can design the model for that as well. Uh, but I think that's a nice, I definitely agree that it will, creating new evals will shape where we set the next milestone and we all move towards that. So like we should be thinking about what is important and what we want to, where we want to get, and then designing the eval to measure the progress uh, there. Yeah. And I do know you have also worked closely with on the policy side, and you mentioned also this like the societal impact of this technology. And I want to hear your thoughts about how do you think, especially community-led research, can have an impact on policy and societal outcome of this technology?
Yeah, I mean, especially important for community members in developing nations, right? Like there's really like the governments need our help uh to learn more about the technology. Like it's moving quite fast. And so I see the role of key experts around the world. Uh, hey, volunteer your time to actually advise the government, like whatever that means for you, right? Like whether that's reaching out to like your local representatives or like seeing if there's national AI efforts to sort of solicit this kind of advice. But really, like the risk to bad AI policy is from ignorance, not from ill intent, right? Like everyone is basically trying to make sense of the technology and make sure that we don't harm people, right? With like in past deployments, past wide deployments of tech. And so, you know, staying engaged, like staying informed first and foremost, and then staying engaged and being able to be a sounding board for policymakers is, especially important at this time. Especially if you're in a developing country, like you could be like the one advisor that they're looking for, and because I know for sure in developed countries like they're starved of advice, like they actually don't have enough information to do policy well, and so that's why we've had to engage so much. But I'm sure this is like a problem that's like order of magnitude more difficult to get like proper advice if you're in a more developing nation.
Yeah, I agree. And as someone who really was one of the open science leaders, what is your, if you have to have like one single important advice to upcoming people who wants to lead open science initiatives? And I'm sure in this community are people who are really inspiring to do that. What do you think they should be thinking about, how they should be going about to make their impact in open science?
I would, yeah. I mean, I think there's a lot you could do. I guess what I'm about to say is very biased based on my background, but like I think at a minimum you need to know how to like use a computer well. So what that means is like programming. I think being able to code and like leverage the power of the computer first and foremost, just the computer. Um, leverage the computer to like help you run experiments, like script stuff, right? And make sure you have that foundation for using the technology to do your science, whatever space that is, right? Even if you're doing political science, right? Being able to code, being able to like interpret data, that's part of the job. It's especially important, of course. And then yeah, after that, it's like if you know how to code, you can basically start right away, right? Like I think a lot of folks they hear all this stuff about LLMs these days you need a ton of compute to even start anything. Like I don't think that's true. Like I think you could start at the minimum you could like publish a paper about a really great eval. You could build a really great eval even if you have no compute. um but yeah, like I don't think compute is a necessary prerequisite. It's necessary, but not sorry, it's sufficient, but not necessary. Yeah, that's the way to
Yeah.
frame.
Uh,
So I think you have to be creative, obviously. Like you have to know how to use your tools. You have to know how to be creative. You have to like have the determination to like look for problems, find a solution, and like actually try things. And then all the other research principles apply, right? You have to be like extremely organized, extremely disciplined. You write that, like document everything. Make sure your experiments are sound, right? Like all these like principles still apply. And then yeah, definitely make use of AI. Like there's a lot of opportunities with with AI helping with your research, right? Deep research for like finding papers that are relevant. So yeah, there's a I think it's even though the problem set and the perceived amount of compute has increased, the tooling for doing research has drastically increased from 2017, I feel like.
Yeah. And based on your journey and your background, I would add that find people who are also as crazy motivated as yourself, and like you did with Aidan and Nick, and connecting that also to the theme of this conference, which is collaboration, and finding other collaborators who would you would all help each other grow and learn and build something that can be impactful. Yeah, I think we are at the time for the first section of the conference. Thanks, Ivan. Any last words for the people?
Honestly, I'm just honored to be here. It blows my mind that there's so many people that care this much about like open science. I'm very humbled, and I'm very thankful for all the community support and everything you're doing. Cohere Labs team is excellent, and I'm excited. I'm happy to be here and excited to keep supporting this effort.
Yeah, great. Thanks. It was really great having you on board as well. Thanks so much.
All right.
And thanks, everyone. I'll pass to Britannia for the next section of the conference.
Thanks so much, Marzieh. Thanks, Ivan. I'm just going to quickly share my screen here. Okay, let's see. Okay, so a quick little spoiler alert. After our lightning talk, so we've got some really exciting lightning talks planned that we'll get to in just a moment. But after the lightning talks, we're excited to try something new with all of you today. We're going to be doing some breakout rooms based on subfields, and it will be really helpful for us if you could just fill out this quick form. You don't even have to put your name. You're just going to click, I think it's 3 multiple choice questions. I promise it will take less than a minute. So you can either scan the QR here if you're gonna just do it quickly on your phone, or I think Madeline, are you able to also drop the link in the chat? Perfect, thank you. So yes, if we could just have everyone do that, everyone on the call, that would be really, really helpful. Feel free to drop in the chat if you have any trouble accessing, but you should be good to go. Okay, thanks so much. I am really excited to kick off our lightning talks today. So we have, I think, 5 lightning talks, all from our community members. So everyone you're about to hear from today are members of our community. No one is internal staff. Everyone is just from our open science space. So I'm really excited to kick off the talks with Bronson and Cato Stephen. And I will pass it over to you guys. Let's see. I'm going to give you guys slide control access, and you should be good to go.
Yes. Good morning, everyone, or good evening. My name is Kato Stephen Maviru, and I co-lead in the Regional Africa Group. And I co-lead that with my other colleague, Bronson. Together with other researchers, we worked on AfriAya. As you can see, based on the first slide, AfriAya came out of our testing of Aya vision model. On the right, you can see an image about African food, but Aya vision couldn't really understand. For us, we can say maybe that's matoke, that's plantain, but that drove us to try to capture a lot of our cultural nuance and languages for vision language models. Next slide, we talk about the gaps that we wanted to bridge. First of all, the lack of data for vision language models, knowing that translation is actually not enough. And Africa itself has a fragmented landscape. You really can't have one language cover everything. So you need to incorporate a lot. Besides that, we found two questions we wanted to work on. Number one, what if we build foundation data sets ourselves? And number two, what if we did it with the entire community? Along the way, this project got a lot of researchers in the community from different countries, researchers from countries like Kenya, a lot, Ghana, Egypt, and so forth. But we had stalled a bit because, the hard work is not easy. So along the way, we found some workarounds, and I guess my colleague Bronson will talk about that. But that's me, and I want to pass on to my colleague Bronson to continue the rest of the slides.
Yeah, and as you can tell from what Stephen has introduced so far, we kind of had a bit of a stumble, but we were able to rebound from that, given the fact that this is our first time leading in such a large expedition. We were able to stumble and come back to that because of the different people who were able to collaborate with us. So you can imagine we were the pilots of this ship, perhaps, but we had so many community champions, and these were people who were actually reaching out saying, I want to include my language as part of this. And we also leveraged AI massively to help those people, in this case, it was one person per language, to actually vet out some of these bad translations as much as possible. So that made their work easier. Technical experts, people from Cohere Labs, we cannot state enough because they had experience actually doing projects on a large scale with so many different people involved. How do you keep those timelines in check? And so that is generally how you see a community coming together to actually collaborate and do something that is quite massive on the scale of a continent. So really, the spark was then grew into this whole thing, and we're able to win the gold prize at this year's Cohere Labs I expedition. But this was all because of the input and all the work that came from all the different collaborators. Sorry about that. Just going back. So what do we actually have in terms of impact? I think I've moved the slides. My bad. My bad. So the impact, in terms of impact, we actually had 13 plus languages. We had 2,400 human quality reviewed data pairs, and we had one huge foundation data set. We have 10 more languages that are not yet added, and we actually are going to add those in version 2. So really, what did we learn from this encounter in terms of collaboration? So enthusiasm is the spark, but you actually need a structure, and that is going to be your engine. So in terms of actually having passion, that's good, but you actually need to have firm goals, you need to have firm deadlines, and you need to be able to switch or progress in case those deadlines are not hit. The next thing is that AI can empower human collaboration and not just replace it. And so that means that you need to actually leverage AI as much as possible to make it easier for the actual people who are doing this work for you. So, as we're closing out, I think the theme that we're going for here is that you can see how collaboration actually helps turn a very tiny project and a very tiny idea into this whole thing where we're able to have a foundational data set for Africa vision language models that was not possible before, and they understand our culture. So we call you upon this journey to basically go ahead and come out to the link, check out AfriAya. We have a version 2 that's on the way, and we're really excited. We think that this is going to be the flywheel for what is yet to come in the future, and all of these different cultural data sets we hope to build on top of this. And so we think that collaboration is really the key that was impossible, that made this thing possible in the first place. And so we're really glad to connect with everyone and continue building on top of this. Thank you so much. I'll be handing it over to the next speaker. That will be Diraj. Thank you so much.
Thank you, Bunsen and Kato. That was really cool. Okay, I'll get started with my slides. Hi, I'm Dheeraj Varghese, and I'm going to be talking about Babu, which is all about efficient multilingual image generation. Oops. Okay. The slides are a bit slow. Okay. Yeah, so as you probably guessed, the problem that we tackle is a monolingual AI world, especially on the task of text-to-image generation, where CR models serve 5% of the world's native speakers. And as we know in the Cohere community, this creates significant barrier to global access. So that's what we tackled. And what we got was the slides are really slow on my, okay. Yeah, what we got was a state-of-the-art model for English while being 2 times smaller and natively providing support for 6 languages. Another thing that we observe from the landscape of models is limited openness in this space, and that's something that we focus on being fully open. Okay, let's go over a summary of our contributions quickly. Okay. We create a multilingual data set where we expanded existing standard benchmark data sets in the field to their multilingual variants, a unified multimodal architecture, a training pipeline that goes from progressively from pixel dependency learning all the way to high resolution instruction tuning. We also extend standard existing benchmarks in the field, which were previously English only, to their multilingual variants. Okay. Yeah. So what can the model do? Of course, it can handle text to image generation, but it also supports creative applications like extrapolation and painting. And what extrapolation is suppose you have an image and you want to add a character to the right, an extra character, and you want to say that in Dutch. And your friend wants to add their character and they want to say that in Persian. Our model supports that, and that's pretty cool for creative applications. In painting is, let's say you have an image of red wine and you want to actually make it white wine. Our model supports that to do this conversion in a prompt that's given in Dutch. What we also observe through our experiments is that the model gets this emergent code switching capability where our model remains robust to mixed language prompts while capturing what you mean in the image space. Yes, the slides take so long for me to switch. I don't know why. Okay, so the next slide, I hope you can see it. It's about how Near Bubble came to life. Is it that slide? Maybe my internet's spotty. Okay. Okay, yeah. It all began with a simple outreach, really. We were really all diving deep into multimodality at the time, and we were looking into what's missing and what's lacking in the field. And what we found was this lack of natively multilingual image generation model, which is not having truth towers, and that led us to writing a concrete proposal, which were 4 pieces of our ambitious project. And getting there was important, but what really brought it to life was continuous collaborative effort throughout, which is the last 4th piece to it. And that would not have been possible without really the supportive and accessible mentorship from Marzieh. Okay, the last slide. What did we learn and what's next? What we learned is that collaboration accelerates progress. And what I mean by that is setting up your loop of experiment, evaluate, and communicate. What I really mean is to get to the communicate part, because you go through the experiment and evaluate, and you bring your reports to your collaborators, and they bring in their valuable inputs based on the clear focus of what you want to evaluate on and what you want to improve. And that really pushes you forward on what you want to achieve and what the next steps are. And I think that for this project, I'm kind of in that communicate section still, because I still have open questions that I want to communicate to our community. And the 3 that are on right now, on my mind right now, is how to extend Near Bubble to more languages, how multilingual representations overlap inside multimodal models, and how can we post-train cultural aspects into these models, which is really important right now. Okay, so I end this talk with a call to join us to cultural conversation. Reach out to me on my LinkedIn if you find these questions interesting. Thank you. Next up, we have Angelica.
Hello, everyone.
Yes.
Do I have,
So-
okay, I do have slide control now. You can hear me, right? Awesome. Okay, perfect. So, hi, my name is Angelica. I'm a PhD student in PFL, and I'm going to talk to you today about the work that it was accepted and presented in iClear this year as a spotlight paper, which is called Include. It has to do about multilingual evaluation and how we can make it better. So usually how we evaluate multilingual LLMs is that we take an existing benchmark, let's say like MMOU, and then we translate it to different languages, and then we evaluate the performance of the model on these languages. The problem with this approach is that usually these translations, they fail to capture these cultural nuances that exist in actual user queries. So for example, if I have the question like, what is the blood alcohol limit for driving? Based on where I ask this question, I might get a completely different answer. So what we want for the models is not just to capture global knowledge and transfer it across different languages, but we want also to encode in the first place regional and cultural knowledge. And therefore, that's why we try to build the benchmark. And we wanted to do that. So the whole motivation behind is that, okay, we need to find native speakers that can help us, find resources in their native language that can capture these kind of dimensions that I just mentioned. And of course, in my lab in EPFL, we have people that obviously they come from different countries. However, it was really hard for us to scale and to find all these different languages that we wanted to capture. And we saw at the same time that Cohere Labs was working on this, as it was very interesting. We contacted them. They were very interested to collaborate with us and merge our forces. And basically that led to, and also they have this amazing Aya community that is like the multilingual community of speakers. And also they have a huge know-how on training and evaluating multilingual models. So it was like a win-win for both sides. So what we did is that we deployed all these speakers and we collected more than 200,000 multiple choice questions from exams across 44 languages, 15 scripts, and we collected more than 750 original sources. And you can see here the different academic fields of the knowledge that we have collected, benchmark data. And then we have also a variety of high, medium, and low resource languages. So having this amazing benchmark now, let's see how LLMs perform on our benchmark. So as we expected, bigger models perform better. However, what is interesting is that the instruction Turing variants of the model, they don't perform that well, and sometimes the performance is even hurt. And this is probably because of how we do post-training and how the data, they're English-heavy post-training data sets. So we need to redesign and rethink how we do post-training for the multilingual case. Another interesting result and analysis that we did is that we stratified the results based on whether the model was trained on the language, whether it was trained on the script, or whether the language was completely agnostic. And we found that pretty much open models transfer 20% more to unseen languages with shared scripts than to those with different ones. And final interesting analysis, and I'm going to stop with the findings. You can find everything on the paper. We actually try to investigate how models, they generate information when they're prompted with different languages. And we found something very interesting, and that every, based on the language and how high or low resource it is based on the model, we might have a completely different generation pattern. So sometimes if there is a high resource language, the model performs answers immediately the answer with certainty. If it's a low resource, it tends to be more verbose. So if you have to take one key takeaway from the whole paper and the whole presentation, is that what we usually do is that we have existing pipelines for English data and for English evaluations. And when we try to transfer this to different languages, we fail to adjust and adapt this kind of pipelines to the specific needs of its language. And I think that is one of the biggest takeaways. We need to redesign and rethink how we do the multilingual evaluation to capture all these different dimensions. We have, as I said, this was a published work. We have published also and released 3 versions of our data set. The first one, the base one, is a classic benchmark, all-purpose benchmark artifact. Then we have a light version, which is a smaller version and can be used, for continuous evaluation during pre-training. And then we have all the data that we will gradually release to avoid data contamination. Yeah, that's all for me. You can find the paper on arXiv and also on the Proceedings of iClear and all these available resources on Hugging Face.
We'll go ahead and pass it over to Harsha next.
Hi, thank you, Petrana. So, hi, guys, just for some background. So, my name's Harsha, and I've been a member of the community for a while now. It's been 3 years. And also, I coincidentally joined towards the tail end of 4.ai, so that's another interesting tidbit. Currently, I co-lead the efficiency subfield in the community as well as the theory subfield. And my primary area of interest is in deep learning efficiency, but I've also been focusing on evals, as Ivan said, it's a big problem these days. So here I'm here to talk about a collaboration that was sparked by this message from Sarah. She posted that herself and Dr. Fioretto, who is a professor at that time at Syracuse, now at University of Virginia, they're embarking on a project where they wanted to extend prior work they had understood about randomness in neural network training and how the impact of tooling and GPUs and those kind of things impacted the training process. And I'm very particular about this, and it's something that's very interesting for me, how tooling affects our choices. And I hopped on, I reached out, and I got a chance to work on this paper. So what this led to is, let's see if the slide changes. Awesome. So what this led to is an investigation on how the fairness impacts of hardware selection are typically not something you see side by side, fairness and hardware selection. This was a joint collaboration with Nishant, also from the community, and Kwang, who was a PhD student of Dr. Fioretto, Sarah, and Fernando Fioretto. So the question we sort of discussed here is beyond just as a utility, does the hardware and the tooling that you use to train a model impact properties of the model? So how does this impact, say, the generalization and other components? So in this work, okay, let's try to see it. Yeah, so how does the choice of hardware impact generalization properties and by extension fairness? So if we could somehow characterize the differences of if you control all the software aspects to the extent possible, like random seed, initialization, data loading order even, and augmentations, do you still see some sort of variance, or do you see a difference if you just change the hardware compared to a reference hardware? And what we did is we observed exactly that. We saw that there were group-wise accuracy differences across GPU generations. And we saw that in imbalanced data sets as well as balanced data sets. But we saw that there is a large disparity in these long-tail data sets where one class is a clear minority in terms of the samples. And that's shown briefly in this plot. So we did a whole analysis overall of this in our paper. And this was published at ICML. Okay, let's go to the next slide. But I briefly want to talk about my lessons from this collaboration. I was in Germany at the time, and my collaborators were in Canada and the United States. So it was a huge time zone difference, but it took a lot of perseverance with everyone involved in this project, different deadlines, different time zones, and all the support Cohere Labs provided in terms of compute was amazing in making this paper come to fruition. I learned a lot about framing and collaboration and even presentation. It's very important on how you present your questions and how you develop it. And I'm happy to say it defines my research taste that I even speak about right now and others in the community know about. As a final sort of outcome is this paper was presented at ICML 2024, and I had an amazing time meeting there, even from the community. I got an internship at the conference, and it also led to the current PhD position I'm working in. So I'd say that if anybody asks, can you participate in Cohere Labs and can it define your career, I can say yes. And I would say I'm thankful to everyone I met in this group. So thanks a lot. And I will now hand it over to Abdul Rahman for his presentation. Cheers. Thanks, guys.
Thank you, Sri. Hi, everyone. My name is Abdurrahman. Today, I'm going to be talking about our recently accepted paper at Column. It's called Do Bias Models Have Bias Thoughts? And as the name suggests, this paper is trying to understand if models that take biased or racist decisions are driven by biased thoughts. This is basically the question that we're trying to answer in this work. So to give you more context, let me just give you an example. So imagine you tell an LLM there's this person from race A and there's this other person from another race, and they're both at the courthouse. Who do you think is using drugs? And you tell the LLM that there's three options, person A, person B, or I don't know. So obviously, if the model says it's person A or person B, it's a biased response because there's no evidence for that. And if the model says I don't know, then that's a proper response. And you also tell the model to tell us what it thinks before it answers. So let's say the model says it's the person from race A, and the thoughts are saying that people from race A are always connected to drugs and so on. So obviously here, this is a case where the answer is biased, and we have some thoughts kind of supporting this answer. So what we're trying to do is that we're trying to measure the bias in these thoughts such that we know if there is a correlation between having bias in the thinking steps and having bias in the answer. This is what we're trying to do. So given that as of now, there is no such method that measures bias in the thinking steps, we decided to propose our own. So obviously you can measure bias in the answer, but you cannot really measure bias in the thoughts, especially when they're like longer than this simple example. So we took a step back. We decided that we actually need to know how to measure bias in the thinking steps. We proposed a method. We called it BRAIN. So the way BRAIN works, if you consider the same example, two people from different races are at the courthouse who's using drugs. Again, the model is generating its thoughts, and also it has specific answer. So the way BRAIN works is that you answer this question twice. In the first time, you answer without looking at the thoughts, and you provide a probability distribution, probability of option A, probability of option B, and probability of option C. Person A, person B, or I don't know. And again, you answer the question while actually including the thoughts. So again, you will have a different probability distribution. And the hypothesis is that if the thoughts are, extremely biased, they would change the probability distribution by a lot. So the probability distribution would be very different when you condition on the thoughts compared to when you do not condition on the thoughts. So a simple way would be just measuring, some KL divergence or JS divergence between the two probability distributions when you condition on the thoughts and when you do not condition on the thoughts. It's as simple as that. So that's our approach to measure bias in the thoughts. And now that we know how to measure bias in the thoughts, we go back to our original question, which is, do biased models have biased thoughts? It's simply measuring the correlation. So we took 11 different biases and 5 different models, and we measured whether or not there is a correlation between bias in the thinking steps and bias in the decisions. And the answer was that there is no strong correlation, which means that LLMs can take biased decisions without necessarily having any biased thoughts, or vice versa. So what I'm trying to say as a conclusion is that LLMs are not like us. They can take biased decisions without having biased thoughts. Humans are not like that. Humans, when they take biased decisions, they have also a biased mindset supporting this decision. Thank you so much for listening. This is the paper. This is the QR code. If you're interested in checking it out, it's an accepted paper at Column this year. And I actually have to thank people whom I work with, because they did all of the hard work. I was just providing guidance, but Swati, Reem, and Shivang, they did all the hard work. And going back to the question of open science, it is actually open science. We met at the Cohere Research Connections, and I was really impressed by their progress. They did all of the experiments. I was just providing guidance. So thank you so much for listening.